Example 1 is an infinite limit statement that we're going to prove using the epsilon-delta definition of a limit. Here we have the limit as x goes to 2 of 1 over x minus 2 squared is positive infinity. Since here we have a limit that goes to positive infinity rather than to some finite number L, rather than wanting our y values to be within epsilon of L, we're going to want our y values to be bigger than some positive number m. So we're going to start by letting this number m be given to us. So we assume that someone's given us this positive number m. We want to find a corresponding delta such that as long as the x values are within delta of 2, the y values are going to be bigger than m. So we can also assume that the x values are going to be within delta of 2, that the absolute value of x minus 2 is going to be less than delta. We want to say, what does this say about the corresponding y values? What does this say about 1 over x minus 2 squared? Well, x minus 2 squared is the same thing as the absolute value of x minus 2 squared. This is because x minus 2 squared is always going to be a positive number. So if we take the absolute value, make it positive, and then square it, it's the same thing as just squaring it right off the bat. So we want this number to be bigger than m. So if the absolute value of x minus 2 is less than delta, what can we say about 1 over the absolute value of x minus 2 squared? Well, the absolute value of x minus 2 squared is going to be less than delta squared. It's because if you square a number, its square is going to be smaller than the square of delta. So now, what can we say about 1 over the absolute value of x minus 2 squared? Well, if we make the denominator smaller than something, the fraction itself is going to be bigger than 1 over that same thing. Basically, if the denominator is smaller, the fraction is going to be bigger. So if we take 1 over the absolute value of x minus 2 squared, that's going to be bigger than 1 over delta squared. So f of x here is bigger than 1 over delta squared. So basically we want our m to be equal to 1 over delta squared. Well, if m is 1 over delta squared, we can rearrange this to say that 1 over m is delta squared. So we can pick our delta to be the square root of 1 over m. And if we pick our delta this way, to be the square root of 1 over m, then in fact, our f of x is going to be bigger than 1 over delta squared, which is going to be equal to m. So our f of x is going to be bigger than m, as long as the distance between x and 2 is smaller than delta. So we found a delta for the given m, and proven that this limit does in fact go to positive infinity.